So welcome to the project demonstration of wireless mobile phone charging system. We are using EMF signal transmitting to the transmitter coil, and the same EMF signal will be received by the receiver coil. So it will be induced and it will provide us the same voltage with same frequency. So here the flow is, we are providing 230 volts AC input to this transformer, so which will step down the 230 volts AC to 24 volts AC with 50 hertz of frequency. So this is the 3 amp transformer we are using. So the 3 amps current will be provided to this pulse generator. So here we are providing generating 50 kilohertz of AC pulses. So for that, first of all, we need to convert this 24 volts AC to 24 volts DC, because 50 hertz signal can't transmit the power for longer distance. So for that purpose, we need to provide the high frequency AC signal. So for that, first of all, we need to convert the 24 volts AC to 24 volts DC. So that will be done by this diode and this filter. So the diode will convert the AC to DC, and the capacitor will remove the pulses after converting into the pulsating DC. So after this capacitor, we will get the 24 volts of pure DC voltage. So now, with help of this LC oscillator, L is the inductor, C is the capacitor. So LC oscillator will generate the 50 kilohertz of frequency, and that frequency pulses will given as input to the gates of these two MOSFETs. So here we are using IRF 544N MOSFETs we are using. So that signals getting from this one given as signal to the gates, and from there we are going to provide the 24 volts AC 500 kilohertz of frequency signal with 3 amps current. So that signal is given as input to this center tap copper coil. So here we can see the center tapping one. So this is the middle, and this is the plus, and this is the plus. So there is the center tapping transformer coil will be acting as a transmitter. So when we place the another external copper coil, so it will induce that, and there will get the same 24 volts 3 amp current and 500 kilohertz AC signal. So if you want to charge a battery or a mobile phone, then we need to convert that AC to DC with help of this regulated power supply board. So it has the two stages. One is the rectification, means we are going to convert the AC to pulsating DC, and to remove the pulses we are making use of a capacitor for smoothing purpose. So now the pulses will be removed and we will get the 12 volts pure DC voltage, 24 volts pure DC voltage. And we need to provide the 5 volts power supply to charge our mobile phone, because mobile phone will take only 5 volts power supply. So for that purpose, we are making use of LM2596, a regulator which can handle up to 2 amps of current. So now this 24 volts pure DC voltage will be converted into 5 volts DC, and that DC is given as input to the mobile phone charging through this universal charging cables. So let us see demonstration. Before on the gauge, so keep a distance between the transmitting and receiving coil, and connect the mobile phone, and now on the transmitter. So when we coming near to this one, there we can see one light on the regular power supply board. So when it is sufficient to charge a mobile phone, this light will get switched on, and we can see that mobile phone is charging now at a distance of 4 to 5 inches. For demonstration purpose, we are making use that. So when this transmitter coil coming near to the receiving coil, so then this MOSFET may get heat up as the power consumption was more by these regulators. Right. Right.